So in this lesson, we are going to talk about passing more complex data types. Specifically, we're going to talk about passing objects between methods. And some weird quirks that happen there that actually violate that rule we talked about in the last lesson where we weren't able to change values. So let's take a look at a code example here. So I have this code example where we're going to look at two different methods. So the first method we're going to take a look at is our change model method. And our change model method takes a car as a parameter, and we're going to set that car equal to a chord. We're going to set the model of that card equal to a chord inside of my method here. Now, up in my main method, I have a car. I've created a new car. I've called it my car. And I give it an initial model of Civic. And then I'm going to print out that model. And then I'm going to change the model to a chord. I'm going to pass in my car. My car gets passed in as an argument. So remember, when we're using and we're calling a method, this is an argument. So from an argument, and this is the parameter. So the parameter here. So my car, we now call it car inside of the method, and we call the method on the car set model. So it has its own method set model, and we change it to a chord. Now, we need to remember something. When I create my car, so I have this car object, my car. It has a little memory space, and that memory space, if you remember, has a reference in it. It has a memory reference. So this reference points to a car object in memory. This is a car object, and it has a string in it called the model. And in this case, we initially set that model to Civic. Okay. Now, Java, when it passes values, we talked about this in previous lesson, it passes values by, or it passes references by value, I should say. So what happens is when Java creates this car object, and it does create this, what it does is it copies whatever is in here. And it copies that value and it puts it into a new reference location. So we have a new reference location called car. And this car has the same reference information as the previous one because it gets copied down here. So it also points to the same car object that's sitting in memory. So when I call the set model method, I am then going to change this to a chord within this car object. And my car is still pointing to the same object here. So when I exit out of my change model method, there's no garbage collecting happening because car is still being pointed to by my car. So this car right here with the Accord model, it's still going to be there. And my car is still referencing that. So when I print my car afterwards, it is now actually going to change what is in here. And this can be very useful, but it can also lead to what we call side effects. So side effects are where we do something like this, where we change something in what is called a mutable object. So these are mutable objects, meaning changeable. Let's say, for example, I have one method calling another method, calling another method, calling another method, and I have this big long chain of methods happening. And maybe I only wanted to change the model of my car here, but it also called some other method somewhere else that also did some other changes, and I ended up with some change that I didn't want. That would be a side effect. So we want to avoid doing this when we can. And we're going to get around how to avoid this when we get to return methods and how to pass information back safely so that we don't have an issue like this where we're manipulating a mutable object. Now, the same does not happen with our primitive data types. With our primitive data types, as we've already seen, I have an int counter here. I print out my counter to check what the value is. I count changes, so then I'm going to increment my count in here. But because this is a primitive data type, what happens is, if we take a look at this, what happens is instead of passing a reference, so I have an integer called counter, and that's going to have a value of 0. When I create my count, it's going to get this value from counter in here, and it's going to be a copy of counter. So that copy, similar to the reference copy, will be manipulated, but because it's not a reference, because it is an actual value, count does not change counter. Something to note is that strings are immutable. We've talked about this before. Strings cannot change. Which means that these act much like primitives in methods. So strings are an object that we've talked about before, but strings are immutable, so they can't change. So they're going to behave, even though they're different, they're going to behave very similarly to our primitive data types when we're passing them back and forth within our methods. So we can't change strings. And one of the reasons we can't change strings is to avoid side effects. That was something that the builders of Java realized that we want to avoid, and since it is such a common data type, we don't allow changes, so we can't have any side effects on our strings. All right, so that is pass by value. There's going to be a link down below with this code. You can play around with it, take a look at the car class, change some things around, and have a little bit of fun. All right, I will see you guys in the next lesson.